Dear all, welcome back to our next session of the Thursday webinar series. In India, we've seen a lot of software innovations. However, if we want to achieve the goal of Atmanirbhar Bharat, we need to create an ecosystem to nurture hardware innovations and physical products. Many startup support systems are now offering a prototyping facility to enable the same. Today, we have Dr. Anantha Prasad, Dr. Madan Sendhil, and Dr. Pavan and Mr. Pavan Kumar, who manages state-of-art prototyping facilities. Dr. Anantha holds a PhD in mechanical engineering with specialization in advanced materials and product design. He has served in various capacities at different institutions and has mentored several students, faculty, and entrepreneurs over a period of nearly 1 decade. As an academician, researcher, and innovator, he was instrumental in setting up of several entrepreneurship development cells, conducting training programs, and handholding budding business enthusiasts. In addition, he has executed various research projects, published research articles in journals of high repute, and has supervised about half a dozen PhD students. He is also a recipient of the prestigious Commonwealth Professional Fellowship and underwent advanced entrepreneurial and leadership training at Loughborough University, UK. Dr. Madan Sendhil, a technocrat and an entrepreneur with leadership experience in education industry and infrastructure development in India, with a vision to be a man to do the undoable. Mr. Sendhil is working towards the goal of bringing up more than 150 successful startups over a period of the next 5 years at AIC Raise, India's first startup incubation center focusing on UN Sustainable Development Goal. He has successfully developed an IT infrastructure company under STPI scheme, which delivered an IT park that houses 2,500 people and 14 IT companies at present. Dr. Sendhil has also received the Edupure Tamil Nadu Award Times of India Group in year 2012. Mr. Pavan Kumar, an engineer by training, believes in creating right conditions for hardware entrepreneurs, makers, and innovators to emerge in India. As a mechanical engineer, he has diverse work experience both in India and in the US. He has worked extensively on various 3D printing technologies from 2008. Today, he's one of the leading facilitators in the maker community and provides consulting towards disruptive thinking and makerpreneurship. As the founder, CEO of Workbench projects, he has spearheaded industry-based grant challenges for organizations like ICRC, OnePlus, GE, Intel, and more. He has been an on-demand TEDx speaker in Bangalore and Pune on future of making and responsible making for a sustainable future. He is also the founder and director of ARTILAB, Assistive and Rehabilitation Technology Innovation Lab Foundation, which is the world's first incubator for assistive rehabilitation and healthcare technology for people with disabilities, funded and supported by DST under the TBI scheme. He is also a member of ISPA. On behalf of AIM, I welcome you all to this discussion. I'd now like to invite Ronak Jogeshwar, who will help moderate the session today. Over to you, Ronak.
Good evening and thank you all for joining at the ZA. My name is Ronak Jogeshwar and I am from the Atal Innovation Mission team at Niti Aayog. I work primarily for the Atal Tinkering Labs initiative and I have been a part of the team for more than 3 years now. As a maker myself, it's really great for me to be a part of this panel discussion and to moderate this panel discussion. And I am very happy to have Mr. Pavan Kumar, Dr. Anantha Prasad and Dr. Madan Sendhil to this conversation. So without any further ado, let's begin. This first question is for Mr. Kumar, Mr. Pavan Kumar. Could you please share about the journey of prototyping and makerspace in India? And how did your journey started? How did Workbench's journey started? And also if you can quickly discuss or share a few things about how or what a typical day at your makerspace looks like.
Sure, I think the question has 3 parts to it. I will try and answer it one by one. And again, I would like to welcome everyone joining this session, and I would like to thank Niti Aayog and AIM for this opportunity to speak at this forum. So I think I will first start with my journey into the makerspaces and Fab Labs and these kind of innovation zones. So I graduated from a very small university in the US with my master's in mechanical engineering in design theory, and then worked for a company that invented 3D printing. So it's called 3D Systems, and started my journey there as an engineer trying to build those systems and working on multiple different technologies, and started seeing the ecosystem there in the US as how prototyping happens when a product idea or an innovation idea occurs to anyone, and especially 3D printing becoming the most important tool that everybody exercises today. But then back in 2006, 2008, when I worked in the company there, it was also very nascent in the US to understand how 3D printing can be useful in these kind of ways. When I came back to India in 2012 and wanted to do something in the education sector, in the sector where a lot of ideas happen, but then how you sort of give shape to them, right? It was very hard for me to understand why India did not have the tools required to quickly come up with those POCs or MVPs that we call to validate an idea that comes into anybody's head or anybody, as a matter of fact. So when we look at these kind of scenarios, it was very baffling to me because I had just come back from the US trying to find spaces where there would be these kind of machines that one could rent or one could use or one could sort of go and sort of take some help with, was not available back in 2012, 2013 time frame. That's when I realized that, like, something had to be done about this. Having that kind of exposure coming from the US, I realized that it's more easier to set up a space and allow different people to come and do these kind of projects or innovations rather than going and looking for it back in the day. So that's how I got into starting Workbench projects, which is a makerspace, a Fab Lab. Today we are doing hardware incubation, so various kinds of things. But we primarily started as an innovation playground. So the second question as to, like, what is the journey of prototyping spaces or maker spaces or Fab Labs uh, coming to from back then to today? I think it's become a very warm community that if you look at, where there's a lot of interesting work, there's a lot of interesting collaborations that were happening uh, over a long period of time, because it's a very niche community that got started from 2013 onwards. And having been front ending this entire movement in India, it is also very heartwarming to see when Niti Aayog wanted to start the adult tinkering labs that were going to be positioned in schools. It was amazing to see that, because it was a perfect segue for whatever work that one was championing from early 2012 to 2013, to see that the national body recognizing the importance of that and putting it in schools, which is the most apt place for people to start with the mindset of tinkering, with the mindset of innovation, with the mindset for doing something with their hands, hearts, and their heads. So I think, as far as I am concerned, and for what I've seen, especially in the COVID times as well, a lot of maker spaces have come together as a community to deliver on a lot of things that is not necessarily to be done by industry, but a gap that could have been plugged very easily with local, just like how our Prime Minister said, vocal for local, right? So that has been plugged as well. So I think as a community, we have come far too ahead, and then everybody is sort of realizing the importance. And I think this very forum and the topic that we are having today emphasizes and reinforces the fact that maker spaces or these kind of innovation playgrounds are really an apt place in an incubator as well, because not just you're talking about tinkering labs, but then you're taking this one step higher to really look at how can you bring innovations and startups to the forefront that are hardware related. Now, coming to a typical day in the maker space, I think it's madness, because first of all, one has to get used to a lot of material, a lot of ideas flung around, a lot of things around us. So it's always, I would not say chaotic, but it's organized chaos, just like our roads and traffic in India, right? We know there's a method to the madness, and there is some way to sort of maneuver through the whole mess that we call as traffic, but then still you will not see people going bonkers. Similarly, I think a day in the makerspace is a lot of people trying to tinker with different things, a lot of conversations happening, a lot of making, breaking, different kinds of activities happening. Of course, learning is constant throughout the day. So I think that's how a typical day unfolds at a makerspace. Over to you, Ronak.
Lovely, lovely. It was absolutely lovely to hear some thoughts from your end at Makerspace and the Workbench projects that we have. Um, my next question is Dr. Prasad. Okay. Dr. Prasad has immense amount of experience when it comes to various institutions, startup ecosystem, and supporting various students and I would say I would take the liberty of saying some of the interesting projects as well in the humongous span of 2 decades that he has been around. So, according to you, what is the fundamental difference when we talk about a prototyping facility, a research facility, and a makerspace? And how do you actually make it self-sustainable financially as an academic institution as well and as a generic institution as well?
Okay. Thanks to Team AIM for the wonderful opportunity given to me and inviting me to share some of my thoughts in this platform. In fact, in the last decade, saw the fall of many multi-billion corporations and the rise of many new startups, and which rose from a few college kids to a multinational cash-rich company. And all of these were directly linked to one thing, which is the innovation and creativity. And this innovation and creativity thinking start from school children to PG students. In fact, for this, the supporting element are the makerspace, rapid prototyping facility, and R&D facilities. In the current scenario, every organization is gearing up to meet the expectations of its stakeholder by setting up a prototyping, research, and even the makerspace facility as well. In fact, to set up these facilities and to make it self-sustainable, an important thing is the who is hosting means the host organization should have an internal expertise in creating these facility. Otherwise, they have to hire it from the outside. So let me give you overview of the facilities one by one. First, I will take the rapid prototyping facility. It comprises of a group of process used to fabricate rapidly a scaled prototype of a product. This may be done using an additive manufacturing technique or with desktop machines like milling, turning, drilling, etc. But in the recent years, additive manufacturing, that is nothing but the 3D printing technologies, are very popular. In fact, additive manufacturing facility allows the multidisciplinary collaborations and reduces the bottleneck between the idea and product. In fact, somebody visualizes an idea, immediately he can convert into a product with the help of a rapid prototyping facility. And coming to the R&D facility, research facility platform for developing ideas, testing, and analyzing the results. In fact, a research center focus on both science and technology, and it should go in parallel, it should go in hand, and it requires a very good sophisticated instrument facility that cater to various segments like chemist, biologist, mechanical engineers, electronics, medicines, healthcare, etc. And even the many organizations have in-house R&D center working towards the societal needs. And as a result, a lot of domain experts and mentors are available across. And I think that is one of the reasons why we are getting a lot of young budding entrepreneurs are coming to our incubation centers today. And coming to the makerspace, Mr. Pavan has given a lot of input, but in a simple way, it's a community-oriented workspace where people with a common interest work together and share their ideas, skills, or often work together on a common project. In fact, today, IoT devices, drones, EVs, medical devices, or perhaps the top beneficiaries of the technology because of these facilities created at the organization or institutions level. To some of my thoughts on this facility, a prototyping is a level of demonstration, research is a level of conceptualization, and makerspace place to get some hands-on trial. And coming to the another important subdivision of the question, which is very important, self-sustainability. Let me give you our own example at Jyothy Institute. we have a state-of-the-art R&D and prototyping facility at our campus, wherein all our AIC incubated startups are one of the beneficiaries of this facility. In fact, our R&D center working in 18 domains of science and technology, starting from water to space. About we have 45 plus PhDs are dedicatedly working in R&D division in the areas of nanoscience and engineering, affordable biomedical devices, ancient Indian science, energy, drones, food technology, biocomposites, etc. In fact, we have also we have a prototyping facility. We have 3D printer, 3D scanner, and also a desktop milling machine, and also a makerspace with a limited facility in the domains of electronics and mechanical engineering. And all these facilities are created about just 3.5 years back. And I would say partially all these labs are self-sustained. So each lab, here is coming with their own product and started their own startup in the lab itself. And this particular center is also called as a Center for Incubation, Innovation, Research and Consultancy, which is an R&D and startups done by the lab faculties are supported by some government funding and also from an investor. And happy to say that almost all our products are in market today. That is one of the reasons we are partially self-sustained. And other self-sustainable model which we have adopted is, they are coming with their own certification and training programs. These certification and training programs more towards the product development and hands-on training on how to use an equipment. And we have a very sophisticated instrument. For that also, we are conducting a training program. That's another revenue model. And the lab faculties are also doing a lot of technical consultancy work. And a few of them have done a technology transfers because we have a very limited manufacturing facility at our campus. And these are all the revenue model which we have adopted. Because of that, about 40 to 50% we are earning our own salary from the R&D and all these facilities in just about 3.5 years. And apart from this, we have also started a small manufacturing and fabrication unit very recently. It is having a CNC turning, CNC milling, and also drilling. And it is completely taken care by our mechanical engineers, and it is running in a 3 shift. It is attached to a development center as well. So it is working like just a normal industry. And also, and all our complete campus is a solar powered. We have a solar power plant on campus. So from the installation to till date, the maintenance is taken care by our own staff. And the excess power which we have generated, we are giving to the grid also. That's another revenue which is coming from the solar power plant. And the institute is also having a biofuel production unit. And all our institute buses are running under the biofuel used by the same production unit. And the excess we are giving to the distributors. That's another model which we have adopted. And we have a biogas unit, which is embedded with IoT module, basically to understand the usage of gas. That's also we are doing. In fact, this is not only the green initiative which we have done, but also it's a revenue model for our facility. And I'm sure these are all the possibilities that one can adopt to make it self-sustainable. Over to Ronak.
Thank you so much, sir. It was actually a great introduction about how the institution also creates a revenue out of the makerspaces as well. So my next question is for Dr. Madan Sendhil. Dr. Madan Sendhil, how does having a prototyping or a makerspace facility that has been described by Dr. Prasad and Dr. Kumar help in product innovation in an incubation center? Maybe you can shed some light on this financial investment and the return on investment of these labs. Do they have a return on investment? And if they do, then how can we actually cash it out? Hello, Dr. Madan, I think you are on mute.
Okay. Thank you, Ranak. I'm sorry about it. And thanks, Mr. Anantha Prasad and Pavan Kumar for a prior detailed presentation. Thanks to AIM for giving me an opportunity on this. So I just wish, I met Dr. Anantha Prasad and Pavan in '94. when I completed my engineering in CIT Coimbatore, and I was seriously entrepreneurial. Even at those times, I wanted to build some electronic devices way back in third year of engineering. My family is from motor pumps business in Coimbatore, so I technically arrived at a product in my mind where a motor will be turned on and turned off for the water levels in the tank. That was the initial thought process which I wanted to make a product and sell it through my own family business arrangements. So when I started working on it, I'm just giving this example. What's the purpose of the makerspaces and why it's very critical? That's the reasoning I'm trying to make out here. So when I wanted to make that product, which is a water level controller, which is available as a product in the market today, it was not available at that point. I really wanted to innovate. And from electronics point of view, I studied electronics. It's not a big deal to find out the level of a water tank and turn it off and turn it on. So it was quite simple. So I wanted to make a product and sell it through the channel. So I started building this product, prototyping it. Obviously using a simple breadboard and some metal pieces and things like that, I was able to basically test the concept very easily at home. But then I kind of wanted to make this as a product, and obviously you don't have the volume perspective in the beginning, right? When you make any product, you don't know whether you're going to sell 5 of them or 10 of them or 50 of them or 500 of them. But at those days, we didn't have these kind of facilities. So I started thinking, okay, I should make the casing, I should make the PCBs and make the product for the particular market. Maybe take 5 initially, make 5 pieces to sell in the market. That's what we thought. Okay. So when we started doing it, I went and built a die for making a cabinet. And then I started making some dies for sheet bending. I started making PCB by printed PCB manually and all that, and tried to make one unit which looks like a product. It took tons of money, and it's certainly unviable. And it literally took about a year's time for me to go take it to my outlet and say, okay, here is a product, you can buy it out and fit it into your motor. That's exactly the problem which all these makerspaces are trying to resolve. So when you have an idea without understanding the volumes of it, we should be able to make a sufficient number of them in a rapid time. Whatever it took for me to do in 1.5 years, it should be doable in a week maximum, maybe in 2-3 days in all our makerspaces facilities which we already have. So 3D print the cabinet. So you create the printable PCB with rapid prototyping methodologies. Then you have different microprocessors, different components which can be assembled together easily. You have testing technologies which can be tested, which can test electronics very easily. So we should be able to make the product in a couple of days and even make 5-10 of them in a marketable manner, take it to the market and try to sell and see the market potential and then expand. That's the sequence in which it should happen. It was not happening, and that's exactly the problem all these makerspaces are trying to resolve. And what ideally we will have in a makerspace to resolve this particular situation is one set of equipments for, obviously, like what I was talking about, the casing and the stickering and things like that. Those are 3D printer, laser cutter. That's all the rapid prototyping related stuff. Vinyl cutting, design softwares for making the designs, computers, plotters, and things like that. Then you have another set of machines which are the CNC machines and the welding machines and all that, so that you can make few pieces right there of whatever you're trying to do. And another set of equipments or woodworking equipments. Then you have textile and jewelry. Your idea might involve textile and jewelry. So you need sewing machine, digital embroidery, plotter, polishing machines, and so on and so forth. That is another set. That's the textile and jewelry for textile and jewelry. Then you need a machine shop to put them all together, milling and things like that. So broadly, there are six categories of equipments which you really need to put it together, so that for any idea, we should be able to deliver in a week's time without understanding the volume. That's the key core part of it. We don't know whether we need 500 or 1,000 pieces. Second part of your question is in terms of the viability of the makerspace. How do we make revenue out of it? So in there are a couple of models which incubation centers follow. That is a membership-based model where people who want to try these makerspaces can have membership over the year, a minimal cost, where they can come in and use all these equipments. Then you have the incubation programs, which incubators like ours run, where they come in there and then we mentor them, we make them into a business, and then we take an equity or we take a fees for running them. So that's another part of the revenue. Then we have the grants and sponsorships from the corporates or from government agencies like AIM or DST and so on. That will be one part. And then we can have training programs in these incubation centers, in this makerspaces. Makerspaces has all different variety of equipments to create a product very quickly. So you can run training programs in the makerspaces, which can also give a revenue for the makerspace. So all these kind of different revenues specifically for the makerspace can justify the investment which goes into it. Initially, it's sort of going to be complex for sure, because the initial investment can range from, something like about 30-40 lakhs to, you can go up to 2 crores, 3 crores to set up a complete makerspace. Depends on what all you want to invest into the whole setup. But then to justify this kind of high level of investment for operating as well, you will need about, you can operate in 5 lakhs a month to about 5 lakhs a year to about 2 crores a year, meaning about 30-40,000 a year to 12,000, 1.2 lakhs to 12 lakhs a year. So to justify all this costing, you need all these different kind of revenues. That's the training revenue. Then you have the membership revenue. Then you have the government sponsorships revenue, which comes in there. Then you will be incubating the companies, which will eventually become successful. And that there has to be equity, which will start giving returns to the incubator. All these things have to fall in place. It will take some time. But then I've been to a lot of makerspaces and incubation centers abroad. I have seen fantastically successful incubators and makerspaces which take equity and make a lot of money out of that. So it is possible to be viable, but you need to be patient, and we need to have right mix of equipments in there, which will be more useful to the community. You can run a community-based incubation center or industry cluster-based. For example, we are sitting right next to industrial park, which is basically a mechanical industry park. So we should select equipments which would be required by them. So if there are industry clusters, we need to leverage them as well. And then the kind of equipments which you put together should be diverse for all different kinds of ideas to be implemented and seen. That's the key part of it. So once you have that, it can be viable over time. You need to be patient for, let's say, about 2-3 years to make it break even and start making money for yourself. So that's how the whole makerspace thing works. And this is there to resolve the problem which I faced in '94. That's what I was trying to make out. Thank you.
Thank you so much, Dr. Madan Sendhil, for your thoughts. I will go back to Pavan. Pavan, could you? I'm pretty sure you must have traveled a lot across the world and tried to understand how the global maker movement is working across the globe. Can you please share some? Share something about some of the global maker movements or maker initiatives which are in sync with the incubation center or makerspaces within India, such as Fab Labs or any other program that you have actually witnessed in your career?
Sure, Ronak, thanks for the question. So I think I will first start off with trying to give a sort of a small perspective on what is the difference between a makerspace and a fab lab as well, because often these are terms that will be used around, and there will be a bit of confusion. Like, are they the same, or what's the point? So makerspaces largely, as we've seen across the world and even in India, are spaces that come with the kind of free flowing attitude you will find people in, like, with just talking ideas, trying to sort of experiment, keep it very exciting, chirpy, and things like those. And then there's a lot of interesting things that are happening in a makerspace. Yes, there would be some training programs. Yes, there would be some other programs, workshops, maybe even a grand challenge happening. But then makerspace spirit is to keep it very free flowing and light. However, people can make whatever out of it as well. But a Fab Lab has a very different rigor to it. A Fab Lab, basically, the Fab Lab stems out of MIT, right? So Neil Gershenfeld, who's the professor from Center for Bits and Atoms, started this back in 2005. And then this was created where he was running a course in MIT called as How to Almost Make Anything, right? So it was a course that was taught to his MIT students where they were taught different things of how a product is made. You will understand it from the electronics point of view, you'll understand it from the design point of view, you'll understand it from the coding point of view. So you do everything in pieces, and then you understand, or you do a project at the end of the whatever course, and you build something from scratch for an idea that came to you. So the Fab Lab has always had a bit of the academic perspective to it, and has always been very directed and focused in learning. So that's why they also run a program called as Fab Academy that gives a lot of merit to a lot of people who want to take that rigorous 6 months course where there's a graduation as well, and then you do a project, and the project has to be unique, and it's an idea that comes to you. Versus a makerspace is something that you can just go with an idea and just try out or fizzle out or whatever that may be. So if you look at the global maker movement, if you look at the Fab Labs as well, they offer quite a distinct flavor to anybody who wants to go there. Now, if you also see how the global movement has shaped any of these, if you take any of these new hardware startup ideas that are coming to the forefront, including several 3D printers that made mainstream, like your MakerBot or any of these, they all have some or the other origin out of a Fab Lab or a makerspace. So that is where, like, whatever your emerging tech that we are so called to as robotics, your IoT, or any of the other things, even Hyperloop, right? So Workbench projects was one of the places where India's first Hyperloop pod was built and taken to LA to try it out in the test track with Elon Musk, right? So that's where we are talking about how it renders itself to the more emerging tech or the more newest of tech, which is also quite crazy out there. Not many people or institutions have the appetite to support these kind of ideas, and that's where these kind of ideas find its home in a makerspace or a fab lab. Now, if you also look at, I'll give another success story of Workbench projects itself, where how ARTILAB Foundation got started. Today, ARTILAB Foundation houses a super Fab Lab. Now, even in the Fab Lab, you will see that there are different sort of layers to a Fab Lab. You'll have the basic Fab Lab, and you'll have an MIT prescribed Fab Lab, and you have a super Fab Lab. Now, the basic Fab Lab is also something that I will not take personally the credit for, but then it's something that we have helped sort of nudge the Fab Foundation to look at. Back in 2015, when we got our Fab Lab status, when we attended the Fab conference that happens in different cities every year, we often bumped to Sherry and Neil, who are the founders of the Fab Foundation, and we told them that India as a country cannot afford your $100,000 lab, because not everybody will have 75, 80 lakhs sitting in their bank to sort of invest in a Fab lab. That's where we said that we cannot also have a lot of machines coming in from Germany, Japan, US, because most of those machines attract a lot of excise duty here as well. And another problem is once you invest in those machines, if they have an issue or if something goes bad, you have to wait for the part to come from one of those origin countries, and again, it's a waste of time. So that's where we had battled it out and probably fought tooth and nail to this, because we said that for people like us who want to create a Fab Lab and create these opportunities as a makerspace or Fab Lab to a lot of people and create a democratic space or a public space where people can come and do projects, we cannot afford to have those kind of expensive machines. So the basic Fab Lab premise was that we could have Indian make machines. For example, there are many Indian make 3D printers which I would vouch and which I would say is fantastic because that's good enough for prototyping. But then unfortunately, back in 2015, 2014, we did not have the luxury. We had to purchase whatever was prescribed in the MIT Fab Foundation list. So that's where, we championed that to happen. And then we also sort of then looked at what the other Fab Labs have to offer, what kind of projects were happening. And those are the kind of programs and workshops that we also offer. Now, if you look at the global movement, that is how it has shaped itself. It was countries like Latin America, India, where we pushed for local machines. Now, if you look at the Super Fab Lab, now Kochi has installed a Super Fab Lab in their midst as well, which is a fantastic facility to do a lot of things. And so do we here. So we have wire EDM, we have water jet, we have some of these machines which are, and a carbon fiber 3D printer. You will not find these in a normal Fab Lab or a makerspace. These are very specialized tools used for specific applications as well. And here at ARTILAB, we pride on the fact that all of these are available for startups and at a very subsidized cost. But apart from that, it is literally free if they are our incubatee for assistive technology. So anybody building anything for assistive technology, you will find ARTILAB as a home. Now, if you look at the global movement and connecting that as well, there has been a lot of focus for makerspaces and Fab Labs towards sustainable development goals, towards assistive technology, towards impactful sort of ideas. So that is where I think the global movement has also found a lot of success and pride to say that Fab Labs, makerspaces, and all of these have enabled people to build these kind of things which might not have been supported by the mainstream as well. Because now, if you go to a VC or if you go to like any other investor, their returns are quite, what they expect is quite crazy, and not every idea can meet that. But if you look at these kind of spaces where any idea that is really impactful will also be given a voice. So that is how I think the global Fab Lab movement or the makerspace movement has really made a change in the world. Over to you, Ronald.
Thank you so much, Pavan, for taking us throughout the globe and sharing your insights about the maker community as a whole. I do have some interesting questions coming from the audience, but I will reserve them towards for the next after the next two questions for Dr. Prasad and Dr. Sendhil. The next question is for Dr. Prasad. How different is it for you as an educational institute to manage such a prototyping facility or a makerspace as compared to what Pavan has shared?
Okay. Most of the educational institutions today are encouraging both students and faculties to come with a novel idea, and which can be translated into a commercial entity by incubating their startups. And as the trend for startups is increasing and catering the needs of young and budding entrepreneurs and meeting their requirements by creating the necessary facility for ideation and functional trials and prototyping has become an imperative. In fact, having set up all these facilities under the one umbrella is a boon to any budding entrepreneurs or a startup who can translate their idea into an action in a quick section or to keep the pace with a rapidly progressing and advancing the world of business. In my opinion, industry can be a specific domain oriented with a stiff targets, other things, but whereas in educational institutes create a platform for students to get equipped themselves to enter into an industry. In fact, an academic research institution is more flexible and better suited to handle with a large pool of mentors and students will come with a out of the thinking, as there are no biases for solutions and they are not worried about the failure or a success. In fact, an educational institute having a rapid prototyping facility, makerspace, and an R&D facility will result in an excellent incubation center, create an excellent startup ecosystem. And also, this will become the this will be the good input for an industry as well. Over to you, Ronak.
Thank you so much, sir. Thank you so much, sir, for sharing such interesting light on how an education institute is actually managing a prototyping facility or a makerspace as such. My next question is for Dr. Sendhil. Uh, what do you think an ideal prototyping facility, hardware prototyping facility or a makerspace should have? What are the different tools and technologies available at your space, and how do you manage these hardware resources, prototyping resources as such?
I keep muted and I keep forgetting. Yeah. So, as far as our particular incubation center and rapid prototyping or the makerspace is concerned, we have obviously the 3D printers. Without 3D printers today, you cannot have a makerspace, of course. And we have the 3D printer, and we have vinyl cutting, laser cutting, and we have the CNC machines, and we have the CNC milling machines, and obviously we have a co-working space anyway in terms of the systems and workspaces with computers. We have arrangement with Microsoft as well as with Amazon for server spaces and various kind of tools for software incubators to come and develop their software related products. We have different microcontroller based kits where people can put together different microcontroller based products. Then when it comes to welding and CNC, we have bench grinders, CNC routers, CNC water jets, and when it comes to wood working machines, then we have the sanders, scroll saw, drill, milter saw, jointer, planer, and there's a whole list of equipments when it comes to textiles and jewelry. Also, we have the embroidery, the stitching machines, different kind of stitching machines, the soldering workstations, where people can put together hardware, which can be tested. Obviously, the oscilloscopes and the spectrometers and things like that. All these kind of things are there in the setup. And in terms of managing this, obviously it's a very complex task, and you need multivariate skills. We have what we did was like many other makerspaces. We also had an agreement with MIT, and in Tamil Nadu we'll be the only Fab Lab which will be working along with MIT. So we went and recruited skills who are trained in Fab Lab. We have 2-3 people who have been trained on multivariate skills managing these different equipments. So that's very much required, because normally people in an educational environment or even from the industry will have probably a very specific skill, and they may not be able to handle all different kinds of equipment over this entire horizon. So it's probably better to get someone from one of the trained Fab Lab trained people, or one of the people who have been trained in other makerspaces. We have 2 such people who have been trained and certified, and that's a requirement, and Fab Lab also to have trained manpower to support to get supported from MIT. So that's probably the way to manage it. Yes, it is a complex process. You need to invest on operating them, because all these different equipments. The one worst thing you can do to a Fab Lab or any of the lab is not using all kinds of equipments. One is you need to attract startups, you need to attract ideas who will use all these different equipments. And you need to have people who are trained in all these different ideas, all these different equipments who will support the startups to try their ideas. These two are very, very critical, apart from investing on the equipments. And that's the only way you can operate a makerspace. Yeah, and that's exactly what we have as well. Over to Ronak.
Thank you so much, sir. Thank you so much, sir. Okay, so now we have some interesting questions from our audience as well. This includes the various incubation centers and our audience on YouTube as well. Yes, one particular question that I would like to take first, and I think this question can be answered by Pavan and definitely be supported by Dr. Madan and Dr. Anantha Prasad as well. That can you please give us some insights on how textiles and garment-based startups could use the Fab Labs? I am really excited to answer this question, but I will let Pavan answer this question first.
Sure. I think that is one of the most up and coming sectors that the Fab Labs are also tapping worldwide. If you look at what a Fab Lab course offers there, just like there's this course called as Fab Academy from Fab Labs, there is also another one called as Fabric Academy. So it is all about fashion design. It is all about fashion technology. It is all about various kinds of things that are happening in the wearable industry, along with apparels as well. Now, if you look at a traditional Fab Lab, there are a few tools that can always render itself, because when I went to the Maker Fair last year as well as a producer in residence, there were quite a lot of innovations around textile and fashion technology as well. There were people doing printable electronics on the fabric, trying to use it for various kinds of applications. There were different kinds of projects being done to look at the future of apparel as well. They were trying to see if you can just 3D print clothing itself using various kinds of mechanisms. So these are also called as various kind of interlocking mechanisms where you can make that into different kinds of clothing apparels. You can also look at various designs being explored very quickly, and then using the laser cutter you can do the patterns for making these kind of prototypes in textile and in fashion. So the basic Fab Lab itself renders itself fantastically for any of these fashion technology and textile based work. But then again, we're always talking from a product point of view. Now, if you had to look at it from a material sourcing point of view, that's a different challenge. Now, in India, when it comes to doing things like these, one has to have the wherewithal to understand what kind of materials can this machine handle. For example, the laser cutter is a very powerful device. There are certain fabrics that would catch fire if you are trying to use it there. But then, of course, you can use leather, you can use various kinds of really resilient material to on the laser cutter. But then let's say if you have something else, which is a finer fabric like cotton or very what do you say, delicate materials, then you'll have to figure out other mechanisms or other machines that you could use to do these kind of operations. Now, coming to the electronics point of view, of course, the Fab Lab is more than adapt to render itself to anything that has to do with electronics, because a lot of today's technology are also talking about wearable sensors being interwoven into gloves. They're talking about things into the fabric itself. There are even conductive ink that is happening. So there are various kinds of things that are available generally. And I think Fab Lab or a makerspace becomes the first go-to space for any idea to emerge there. Over to you, Rona.
Okay, thank you.
Thank you. I think I will also request Dr. Madan and Dr. Anantha if they have any comments on this to answer. And after that, I will also share some of my personal experiences with makerspaces as well on this particular question.
Yeah, I would like to share one example here. In fact, in the last year, we have conducted a student innovator program from the Atal Tinkering Lab for the Delhi Public School student. The 7th standard student came with an idea of printing sensor on the cloth on the cloth where easily we can identify the people near us. In fact, this is we have done using a 3D printing technology, and now they are in the process of patenting that particular activity also. So probably we can imagine the 7th standard students are going forward with this kind of a great idea, and I am sure the textile industry will have a lot of future in the coming years. Yeah, over to Rona.
Yeah.
Dr. Madan, if you have any comments on this?
Nothing much on this particular thing, but it's a very large segment with locations like Coimbatore, with Tirupur nearby, and global demand becoming very customization required in terms of whether it's textiles or jewelry. It has, the segment itself has become very, very strong and requirement for agility. People, the customers are requiring different varieties on small quantities is what I hear from different manufacturers over in Coimbatore and Tirupur. So that again re-emphasizes whatever was getting explained by Mr. Pavan and Anantha Prasad, that we need the prototyping concepts, and for textile industry and jewelry industry is also very important. I'm just emphasizing the requirement for it. Yeah.
Okay, thank you so much, all of you. I would also take a quick minute to share my experience as well. So yeah, I would call myself first a maker and an educator as well. I'm a mechanical engineering graduate, and I also started my career with some of the media firms in Mumbai. I hail out of Mumbai. So Fabi Academy, as Pavan has mentioned, there's a Fabi Academy in India. It's in Chandigarh. It's handled by Zeos Makerspace, and then we have another fabrication-based makerspace, which is Fab Lab in Jaipur as well. The beauty of having merging textiles and makerspaces is that you just get amazing amount of work done in a quick manner. Just like architects, fashion designer just quickly make their forms on a 3D design software, laser cut them. Once they get the tech right, the world is their oyster. In fact, I'll also share an example of a leather-based product organization called the Black Canvas, which also hails out from Mumbai. This is a dear friend called Khyati. She's a maker herself, and she actually works on leather and creates really interesting type of materials and products for her audience. So the possibilities are endless when you come down to a maker space. Coming to the next point, I'm pretty sure I'm not going to touch on the financial terms because I think we have already covered that. But coming to the next point is that one more domain which is sometimes not closely connected to a makerspace just because of the fact that a makerspace is more textile, more technology and more hands-on tools heavy is biotech or microbiology. Okay, so what and how does people from biotech, microbiology, or biosciences leverage a makerspace around them? And I can see Pavan smiling, and I'm pretty sure he has a very interesting answer to that as well. So I will again ask Pavan to answer that question and tell us what Workbench has been doing at also with that aspect.
Absolutely. I think one of the guys that reached out to us in our early years of working at Workbench was a guy called Richard, who still works with us. So he quit his job at Kingfisher Breweries, where he was a microbiologist there, and he joined Workbench projects. It was a very surprising thing to us, but then we soon found out that Richard was the exact kind of guy who we wanted to have at our makerspace, because he was the person who was so addicted to microbiology and biology based stuff. So I think I will use my own employee's example here. So Richard has been very successful in using the makerspace to do several things that he is now also in the papers for. He's looked at also cultivating a lot of these worms that eat styrofoam for reducing plastic waste. So he built enclosures in the makerspace for that, and then reared a lot of these worms. He also looked at building vertical gardens there with a bit of electronics in them and trying to figure out something. So that's your hydroponics, and you have your various kinds of vertical gardening techniques. Then we also did a lot of recycling, upcycling workshop for kitchen gardens, where Richard has successfully run that. He's also built a tank that can cultivate larvae that eat or maybe different kinds of things that are suspended in water that eats the larva of mosquitoes. So he's done that project in our space. He also worked on another project called as edible water bottles, which uses alginate to create a skin that you can store water, and then you just pop that, and then you can actually have the entire water bubble. So you don't have to again use plastic bottles to store water. So I think all of these projects, and of course, he's trying to make leather out of mushroom that he's trying to harvest. So various kinds of things that Richard has used our own makerspace to create several POCs for these kind of projects. And I think he has been fairly successful because there, one, the community comes together and works with him as well. There are people who come and say, hey, Richard, I like the idea that you shared in the last meeting. Can I join your team? Can I work on this project? Right? And then the project sort of gets done. So similarly, there were many a times that, like, he has opened up the ideas to others. Others have also made it for themselves. Somebody tried to do various ways of trying to reduce carbon footprint. So things like these get done, and then this is the whole bio angle to the Fab Lab and things like those. Over to you, Ronan.
That's pretty interesting to hear. Dr. Madan, Dr. Anantha, if you have any follow-up comments on this.
Well, Pavan has detailed it pretty well, so I will leave it at that.
Oh, sure.
Okay. Probably the food biotechnology is one area. Probably the students can focus on that.
Yes, sir.
And under the food biotechnology at present, under the COVID-19 situation, probably immunity booster is one of the main activity which is going on in our at the AIC, and many of the students from postgraduate student with the biotechnology and microbiology students are working on this particular thing. And another probably idea is working on the milk protein. So is the another the present trend, probably working on the beta-lactoglobulin. All those things will be the better option, especially working on the biotechnology or a microbiologist. Yeah. Over to Ronak.
Thank you so much, sir. Thank you so much. So we are getting a lot of interesting questions, but due to paucity of time, we would restrain from taking one more question. Rest of the questions can be emailed to the incubator ID. The incubation centers can send us the official incubator ID their questions, and we try to answer as much as we can. I'll just take this last question, which is again really interesting and which is actually action oriented, I would say. How can the incubation center network, or how can the incubation centers of India connect with the prototyping / makerspace community of India and across the world? So, Dr. Madan and Dr. Anantha, would you like to answer this question first, and then we can move on?
Yeah. Yeah. In fact, Sir, please go ahead. Please go ahead.
Go ahead. I was just go ahead, sir. Please go ahead.
Okay. In fact, as per the mandate, one of the mandate or the target from the Atal Innovation Mission for the incubation centers is the networking activity. In fact, that is one of the most promising activity for an incubation center. We are collaborated with more than 24 academic institutes across Karnataka and in a different districts. And say, for example, we have a 3D printing, say, for example, ABS and PLA material is used in our the college, which is networked in our area, which is in Belagaum. They have a metal 3D printing. So collaboratively, we are doing this kind of an activity with these collaborate with the academic partners. So probably this can be strengthened by each incubation center to utilize their institute facility, and also we can share our facility to the academic partners. So this is my thought on your question, Mr. Rona.
Dr. Prasad, over to you.
Dr. Prasad spoke, I think.
Dr. Prasad, you are on mute, sir.
No, I have already shared my view.
No, Dr. Prasad is the one who spoke, I think.
Yeah.
I seconded basically. So what we did once we are just 1 year old in terms of the incubation center setup itself. So we started networking through the AICT's network of innovation cells, and AICT has been supporting entrepreneurship centers in different institutions already. So we started managing some of their incubation entrepreneurship centers, and then different ideas pop in. Obviously, in a lot of institutions out of different schemes, there are prototyping labs independent of incubation centers also. For example, PSG, they have a very exhaustive rapid prototyping in terms of laser cutting and prototyping machines, for which government TBI, under TBI, they have gotten 5 crores long back. So there are certain products which are there in institutions and labs. Our Citra is another in Coimbatore, which has exhaustive prototyping and lab for textiles. So obviously we network with all of them. AIM supports, there are forums in AIM, there is connectivity through TBI, and there are connectivity through CII and different forums. We connect through them, we understand what are the different facilities which are available. We tell our startups, obviously when a startup comes in with a unique requirement for a different equipments, it may not make sense to invest in that equipment for every startup. So unless we understand what's available in the entire community, we may not be able to run an efficient makerspace also. At the same time, unless we keep telling out what we have and make other people come to us, which is certainly a revenue part for the makerspace. So this connectivity is what makes the makerspace viable by itself. That's one reason why all the different incubation centers and the makerspace and the independent labs are very well connected, in my opinion. Yeah. Go ahead.
Pavan, would you like to share your thoughts on this?
Sure. I think I'll give a very different perspective than my peers here, Mr. Sendhil and Dr. Sendhil and Dr. Prasad. So for me, it's always about the larger community. For me, it's always about trying to figure out how all of this can impact very well together. Because right from the start of the idea to the impact that actually happens, because the product has to be built and it has to be taken as an enterprise. You have to go out to the VC circles and you have to raise money and you have to scale. Right? Otherwise, yes, anything that we create in the lab is great, gives us joy, gives us pleasure because we've spent our heart and sweat into it. But then ultimately, if that doesn't also impact, the creator also does not feel the validity of it. Now, if you look at the networks and the community, especially the international community, they are very active, especially on open source forums. So if a lot of makerspaces and Fab Labs rely on these open source forums, relies on knowledge sharing, relies on, let's say, because if you look at 3D printing and indigenous Indian 3D printing manufacturers, it was not created in India. It was all technologies that was borrowed from the West. And then, yes, there are a bunch of companies that have built really good products based on those kind of open source technologies. If you look at it, Apple itself was built on Linux, and then those are all open source technologies. So that's where I think one has to contribute actively to the open source technology world. One has to actively contribute to those kind of forums, communicate in those kind of forums. And there are many forums that are available for, like, looking at India, looking at world as a global lab, right? Now, if you look at these kind of forums, that is where you'll also derive ideas from, but you'll have to also contribute. And I would like to see more and more of our incubators, more and more of our labs contributing as well and not just taking from it. So that is where I think some of the more grounded ideas, some of the more amazing ideas that India prides itself on, where we are, like, sustainability becomes the core factor, or where we are very good for our jugad that we so call as our mindset. But then we would also like to make that jugad into really frugal innovation. I think there's a huge world of gap between the jugad to become an innovation or a product through frugal innovation process. And I think if one can really create those kind of methodologies or share those kind of ideas to the world as well, right? I think it would become a fantastic sort of place to live in, and the world will only become a better place.
Thanks. Thank you so much, Dr. Madan and Dr. Anantha, for sharing your amazing views and very different and very varied views on how these prototyping facilities and makerspaces can actually help the incubation center network and the hardware prototyping network across the country. I will take a moment and I will just hand it over to Malika, who is the part of the EIC team, to proceed with the next steps.
Thank you, Ronak. I think this was a very engrossing and an illuminating discussion today. So, dear panelists, so for your time and effort for this. I'd also like to thank our audience here and at YouTube for joining us today. We greatly, greatly appreciate your active participation. Thank you, everyone. Stay safe.
Thank you.
Thank you.